Earlier, we indicated that when a transformer is wired conventionally, the ends of the two separate coils that make up the secondary winding are joined together in series at the X2 bushing. The other ends of the coils are connected at the X1 and the X3 bushing, respectively. For Y connections, the secondary coils are often connected together in parallel. In this case, corresponding ends of each of the two coils are connected inside the transformer at the X1 bushing. The other ends of the coil are connected together at the X2 bushing. When secondary coils are connected in parallel, the X3 bushing is not used. Companies generally tape or tag the X3 bushing in some way to alert their workers not to make any electrical connections to the X3 bushing. If a unit with 4 secondary bushings is used, the connections are made outside the transformer by jumpering together the bushings connected to the corresponding end of the windings. The result is still the same. Only 2 connections can be made to the secondary winding. Here we have a simplified illustration of 3 single bushing additive polarity transformers. To make our explanation easier to follow, we've labeled the transformers and their windings 1, 2, and 3. The primary windings of each unit have already been connected to the primary distribution system using a Y connection, as we saw earlier. This primary Y phasor diagram represents that connection. This phasor diagram illustrates the Y connection we're going to make on the secondary side of the 3-phase bank. Notice that the phasor diagrams that illustrate the Y connection are arranged identically. The uppercase letters on this phasor diagram refer to the primary connections and the grounded system neutral. The lowercase letters on this secondary phasor diagram illustrate the secondary connections and the grounded system neutral. Again, as an aid to explaining this connection, we've numbered the windings on the phasor diagrams that correspond to the transformers 1, 2, and 3. As you'll recall, in a Y connection, one end of each winding is connected together at the system neutral. The connection is known as a Y tie. On the secondary side of this bank, we'll use jumpers to connect these ends of the secondary windings attached to the X2 bushings together. We'll then connect this Y tie to the grounded system neutral. With this done, we'll now need to connect the X1 bushing of each unit to the appropriate secondary distribution line. In this example, we'll designate the primary phases on this illustration A, B, and C. We'll designate the secondary lines beneath the grounded neutral, secondary A, secondary B, and secondary C. We'll establish a relationship between the primary and secondary windings that has 0 degrees angular displacement. Whatever primary phase the H1 end of a primary winding is connected to, the X1 end of the secondary winding should be connected to the corresponding secondary line. In this case, the H1 bushing on transformer number 1 is connected to phase A. Therefore, the X1 bushing on transformer number 1 will be connected to secondary line A. Transformer number 2 is connected on the primary side to phase B, so the secondary connection will be made to secondary line B. Finally, transformer 3 is connected to phase C on the primary side, so the secondary X1 bushing on the secondary side is connected to secondary line C. When this is done, there is no phase shift between the primary and the secondary windings of the 3-phase bank, so it has 0 degrees angular displacement. Now that we've seen how this Y connection is made, let's look at the voltage we can expect on the secondary side of this bank. Because the secondary windings are connected in parallel, the transformers used in this bank are rated for 120/208 volts. Connections made between any of the secondary lines and the grounded neutral will supply 120 volts. Connections between any 2 secondary lines will provide 208 volts. Here's the 3-phase bank we'll work on. We can tell this is a Y primary connection because one end of the primary windings has been Y tied at the case ground and connected to the system neutral. We can also see the other end of each primary winding is connected to a phase of the 3-phase system. When properly connected, the bushings on each transformer will look like this. The connection is the X1 bushing. This connection is the X2. Notice that a ground strap has been installed between the transformer housing and the X2 bushing. The strap is used to ground the transformer housing. The X1 bushings on each transformer are tied together using a Y tie and connected to the system neutral. Leads from the X1 bushing on each unit are connected to the appropriate secondary line at the secondary bus. Here's the system neutral. Here's the connection to transformer number 1. Here's the connection to transformer number 2. And here's the connection to transformer number 3. 120 volts is supplied between connections to any secondary line and the system neutral. 208 volts is supplied by any connections to any two of the secondary lines.